Good day everyone! Welcome back to General Mathematics. It is still me, Engineer Adrian Miguel S. Omengan. And we are still under the inverse function. Let's now proceed to inverse function LBV GMAT 1-3.4 to 1-3.5. For this section, the most essential learning competency finds the domain and range of an inverse function and solves problems involving inverse functions. The topics under this are the domain and range of inverse function and problems involving inverse function. In line with the most essential learning competencies, the following are our learning objectives. By the end of this video, we want to determine the domain and range of an inverse function and to solve problems involving inverse function. Let's go to the domain of inverse function. The domain of an inverse function consists of all real numbers except those values that would make the function undefined. This means the domain is the set of all possible x values which will make the function work and will output real y values. Sometimes, instead of the term possible, we use the word permissible. Our default domain is the set of all real numbers unless there will be exemptions. The exemptions are the values that will make the function undefined. What then makes a function or expression undefined? It is when the denominator becomes 0. When we divide a number by 0, it produces an expression that we cannot solve. We cannot divide by 0, thus making the expression undefined. Let's look at this example. Determine the domain of the inverse function f inverse of x equals 2x plus 1. Since there is no denominator in this expression, we can say that the domain of this function is the set of all real numbers or any number from negative infinity to positive infinity. However, when we say no denominator, this means the denominator is equal to 1. Now let's move to the range of inverse function. The range of an inverse function consists of all real numbers except those values that would make the inverse of the inverse function or the original form undefined. Again, the range does not include the values that would make the inverse of the inverse function undefined. Let's recall that the domain are permissible values of x, and the range is the set of resulting values of y. Same applies with the inverse. Since it is easier to determine the domain of a function, by getting the inverse of the inverse function, it will interchange the x and y values, such that the domain of the inverse function will become the range of the inverse function, and the range of the inverse function will become the domain of the inverse function. Now, by getting the domain of the inverse function, we can determine the range of the inverse function. For the same example, determine the range of the inverse function f inverse of x equals 2x plus 1. Before we proceed, let us first take the inverse of this function. So when we take the inverse of this function, first step, we let f inverse of x be equal to y, giving us y equals 2x plus 1. Next step, interchange x and y, giving us x equals 2y plus 1. Then third step, let's solve for y. We subtract 1 from both sides, we will have x minus 1 equals 2y plus 1 minus 1. When we combine positive 1 and negative 1, it will become 0. Thus, we have x minus 1 equals 2y. We divide both sides by 2. We have x minus 1 all over 2 equals 2y over 2 and cancel 2, thus giving us y equals x minus 1 all over 2. Now that we have the inverse of the inverse function, if we solve for the domain of this, we are basically solving for the range of the inverse function itself. Since the denominator of the inverse function is constant, which is basically the number 2, there is no way that it can be 0. Thus, we can say that the domain of this function is the set of all real numbers, or from negative infinity to positive infinity. But we know that the domain of this function is also the range of this inverse function. Thus, the range of this inverse function is also the set of all real numbers from negative infinity to positive infinity. Let's answer some problems. For problem number 9, determine the domain of the inverse of the function f inverse of x equals 2 over x plus 1. Let us recall that the domain is all permissible values of x that will not make the function undefined. Usually, it is the set of all real numbers. Also, the function will be undefined if its denominator becomes 0. Thus, we will not include this set of values. So, we equate the denominator to 0 so that we will know the exemptions to our domain. So, we have x plus 1 equals 0, thus giving us x equals negative 1. The value x equals negative 1 will make the denominator 0, thus making the function undefined. Therefore, we will not include it, and thus giving us the domain. The domain is the set of all real numbers except negative 1. For problem number 10, determine the range of the inverse of the function f inverse of x equals 1 over x. Let's recall that the range of an inverse function consists of all real numbers except those values that would make the inverse of the inverse function, or the original form, undefined. So basically, to get the range of this inverse function is to get the domain of the inverse function. So first, we will solve for the inverse of the inverse function. Let's first change f inverse of x to y. Then we will have y equals 1 over x. And then, let's interchange x and y. We will have x equals 1 over y. Next step, solve for y. We cross multiply x and y, giving us xy equals 1. We divide both sides by x to get y. So we have y equals 1 over x. The function will be undefined if its denominator becomes 0, thus we will equate the denominator to 0. Looking at this, the denominator is equal to x, thus we have x equals 0. Normally or usually, the domain of the function is the set of all real numbers. However, there will be an exemption which will make the function undefined. Thus, the range of this function is the set of all real numbers except the value 0. Now let's go to problems involving inverse function. There's no better way to learn this than to solve problems, so let's solve some problems. For problem number 11, a right circular cone with a height of h equals 50 centimeters is to be constructed. If the volume of the cone is 200 cubic centimeters, find the radius of the base of the cone. The formula for the volume of the cone is V equals pi r squared h all over 3. Since the problem is looking for radius, let's solve for r in terms of the other variables. First, we cross-multiply. We can see here that we need to cross-multiply 3 and the volume, thus giving us 3v equals pi r squared h. Next, we divide both sides by pi h, giving us 3v over pi h equals pi r squared h all over pi h. Then, we cancel pi h, giving us r squared equals 3v over pi h. Since we are only concerned with the value of r, we take the square root of both sides, giving us square root of 3v over pi h equals square root of r squared. Then we have r equals square root of 3v over pi h. But specifically, the problem is asking for the radius given that the volume equals 200 cubic centimeters and the height is 50 centimeters. So we will just substitute these values to this formula. So we have r equals the square root of 3 times 200 cubic centimeters over pi times 50 centimeters. Input this to your calculator and it will give us the radius of approximately 1.95 centimeters. For problem number 12, to convert from degrees Fahrenheit to Kelvin, we have the function k of t equals 5/9 times the quantity t minus 32 plus 237.15, where t is the temperature in Fahrenheit and Kelvin is the SI unit of temperature. Find the inverse function converting the temperature in Kelvin to degrees Fahrenheit. Basically, we are given this function which converts the degrees Fahrenheit to Kelvin. But the problem is asking for the function that will convert Kelvin to degrees Fahrenheit. So to get this, we will solve for the inverse of this function. So let's solve for t in terms of k. First, we subtract 273.15 from both sides, giving us k minus 273.15 equals 5/9 times the quantity t minus 32 plus 273.15 minus 273.15. If we combine these two quantities, it will become 0, thus giving us k minus 273.15 equals 5/9 times the quantity t minus 32. Next, we multiply both sides by 9/5. So we will have the quantity k minus 273.15 times 9/5 equals 5/9 times the quantity t minus 32 times 9/5. We cancel 5 and we cancel 9, leaving us k minus 273.15 times 9/5 equals t minus 32. And then, we add 32 both sides, giving us the quantity k minus 273.15 times 9/5 plus 32 equals t minus 32 plus 32. If we combine these two quantities, it will become 0, leaving us with t equals 9/5 times k minus 273.15 plus 32. Now, this is the function or the formula for converting Fahrenheit or Kelvin to Fahrenheit. And that's the end of our lecture. What we learned in this video, we determined the domain and range of an inverse function, and we solved problems involving inverse function. In our next video, we will learn exponential functions. For supplementary problems, you may refer to QuexBook General Mathematics Chapter 3.